Today we're going to be working on Module 3, Lesson 1, which is adding integers. You know what? We've already covered this. We've done it some this year, but we're going to go back and we're going to hit it again. This time we're going to hit it with a lot of detail to really get it burned into your brains, because this is a really important skill, everything involving working with integers. Really important stuff that you're going to be carrying all the way through high school and beyond. So, let's go ahead and get started on the lesson. They're going to have us start by doing some problems using algebra tiles. I suspect you've probably used these before. On the algebra tiles we're going to be using are going to be digital ones. You can see that a yellow tile is considered to be a positive one and a red tile is considered to be a negative one. So with that in mind, the problem they want us to model is going to be -2 plus a -3. From there, we would simply do, you've got two negatives right here. There's your -2, and then you're adding 3 negatives to it. There's your -3. What's your solution going to be? Your solution is going to become -5. Now from here, they got a video for us to watch, so let's go ahead and do that and see what that video says about using algebra tiles.
Use algebra tiles to add integers. Use algebra tiles to solve -3 plus -4. Combine 3 -1 tiles with 4 -1 tiles. There are no zero pairs to remove. There are 7 -1 tiles, so -3 plus -4 equals -7. Use algebra tiles to solve 2 plus -6. Combine 2 +1 tiles with 6 -1 tiles.
Now
Remove
watch how
all
the
zero
positive and negative
pairs.
zeros each other out.
There are 4 -1 tiles remaining, so 2 plus -6 equals -4. Use algebra tiles to solve -3 plus 5. Combine 3 -1 tiles with 5 +1 tiles. Remove all zero pairs. There are 2 +1 tiles remaining, so -3 plus 5 equals 2.
That simple. Nothing to do in these things, okay? So with that skill, let's work on a couple of other problems here. So we've got -5 plus a -2. So we've got -1, 2, 3, 4, 5. We're adding a -2 to that. 1, 2. So from there, our answer is, of course, going to end up being -7 for that one. Let's look at another. We can put it in right here, -7, and check our answer, and it checks. Let's do another one. Right. Oh, nope. We got a video on zero pairs. So let's watch this video on zero pairs next.
A pair consisting of a +1 tile and a -1 tile is called a zero pair. The tiles cancel each other out to result in a value of 0.
No, that works pretty good, and considering they've already talked about zero pairs with us, I guess it makes sense that they should give us an actual video for it. You, of course, have the vocab here. One positive algebra tile is paired with one negative algebra tile. The result is going to be a zero pair. The zero pairs can be removed from your workspace. So, with that in mind, let's work this problem. We have a +3, that's 1, 2, 3, and we have a negative, adding a -7. 1, 2, 3, 4, 5, 6, 7. Now from here, we should be able to take and flick off the zero pairs. Those two are gone, those two are gone, and those two are gone. What's your final answer going to end up being? Your final answer is going to be -4, which, they didn't even give us a place to check it. That's sad. Here's another one. Same thing. We're not going to keep wasting time hammering away on these. I'm pretty sure you get how it works with algebra tiles. Now that we understand that, what we really need to do is figure out how to do it with real numbers. And the textbook is going to hammer you with all kinds of number lines and funkies and whatnot. And you know what? I'm not going to spend a lot of time on that, but we're going to look at the first set. So here we got the horizontal number line, and the question they have is move through the slides to model a -3 plus a -4 is equal to a -7. So the first thing they're going to do is they started at 0 over here, and they subtracted 3. That moved them right here. And then they're adding a -4 to it, which they're going to say is subtracting another 4 right there. That gives you the -7 for your final answer. Pretty simple, right? Sure it is. You can also do the same thing on a vertical number line. Here they've got -5 plus a -4. So they start up here at 0. They subtracted 5. They from there subtracted another 4 from it, and they ended up with 9. I have no idea where our graph went. It just flat disappeared. Kind of sad. Let's keep it going. Okay. Now the number lines illustrate the rules for adding two integers. Sorry about that. The two integers with the same sign, and to add two integers with the same sign, you're going to take and add their absolute values, and the sum is going to be, well, both of them are positive, your answer is going to be positive. If both of them are going to be negative, your answer is going to be negative. But that leaves us with some kind of vagueness, which is kind of hard for us to comprehend. So instead, we're going to kick back to doing the problems Mr. Rietz's way. So a problem we have is going to be -4, -7, plus a -2, and we're going to use Mr. Rietz's rules. Hold on just a second. Now, Mr. Rietz's rules are real simple. The first rule is going to be to multiply the sign. And the only time we do that first rule is when you have a situation like that, where you have two signs that are side by side with each other. In this case, we have a positive and a negative that's side by side with each other, and a positive times a negative is, that's right, it's a negative. So now I'm going to get -7 minus 2. And that's going to take us to the next step, which says if the signs are the same, you find the sum. If the signs are different, find the difference. Now, don't want you to get confused over minus and negative, because folks, minus and negative, it means the same exact thing. So right here I have a -7 minus 2. Well, that's the same thing as saying -7 minus 2. The signs are the same. Find the sum. So the sum of that is going to be 9, and then that takes you to step 3. The sign in front of the larger number goes in front of the answer. We're looking for the larger absolute value. Which has a larger absolute value, 7 or 2? Well, that of course is going to be 7. 7 is bigger than 2. 7 is negative, so your final answer is -9. If you use Mr. Rietz's rules, you will get the answer right every single time, unless you make a silly math boo-boo. Now you guys take a minute and work extra example number 1 on your own while I set it up on the board to do. We have -9 plus a -8. I hope you pause the video to solve that. We're going to make that ugly problem pretty by multiplying the signs, and positive times the negatives and negative. So that now gives me -9 minus 8. Step 2, signs are the same. Find the sum. The sum of 9 and 8 is 17. Step 3, sign in front of your larger number goes in front of your answer. 9 is larger than 8. 9 is negative. Your final answer, -17. That is showing your work. That is what I must see. If I see anything less than that on each and every problem of your homework, you've done it just for fun. For example number 2, still adding integers with the same sign here, we've got a problem where Allie borrowed $139 from her parents. That means Allie's negative $139 because she borrowed money to purchase an e-book reader. During the first month, she purchased $47 worth of apps, games, and movies, which was added to the amount she already owed her parents. So she's owing them an additional 47. So we're adding another negative $47, and it wants us to write an integer to represent how much Allie's going to have to pay her folks when it's all said and done. So we're going to start off with the fact that Allie owes a negative $139. And now she added another, was it $47? Let's go back and look real quick. Yep, another $47 to it. So that's going to be adding a negative 47. And from there, we've set up our problem. Step 1 says to make the ugly problem pretty by multiplying the signs. A positive times a negative is a negative. Now I have a negative 139 minus 47. Signs are the same. Find the sum. So let's see, that's going to be 186. And then the sign in front of your larger number goes in front of your answer. 139 is your larger number. It's negative. So your final answer is negative 136. Now you pause the video for a minute and work on this problem on your own. Did you get it done? Let's take a look at it. For this one, Sydney is going shopping with her friends, and for some reason my cursor, there it goes again, is shopping with her friends for her friend's birthday party. She withdraws, that's going to be a negative $37 from her checking account to spend on food. Then she withdraws, that's another negative, another $18 to spend on party supplies, and it wants to know what's the final going to be. Well, she started off by taking $37, and then she added to that $37 another negative $18. Make your ugly problem pretty by multiplying your signs. That's going to give me a negative 37 minus 18. Signs are the same. Find the sum, which is going to be, let's see, 47.55, I do believe. And the sign in front of your larger number, boop, boop, right there, negative 55 is going to be your answer. That is showing your work, folks. That is what I must see. The next concept we have is to learn additive inverses. Here you can see examples of additive inverses are going to be 4 and negative 4. 4 and negative 4 are going to be opposites, and opposites have the same absolute value, but different signs. That's going to be a vocab word, which for some reason does not want to stick. Maybe that's why it wasn't highlighted the first time. Ah, there it went. Then you have two integers that are opposites are called additive inverses. Let's go ahead and highlight that one. And their, guess we should have, I'll call it opposite inverse, and their sum is going to be equal to 0. Okay, so for example, 4 minus 4, additive inverse, they're also opposites. Their sum is going to equal to 0. In words, for the additive inverse, you could say that the sum of any number and its additive inverse is going to equal to 0. If you were to look at it in a mathematical example, positive 4 plus a negative 4, additive inverses. The sum is equal to 0. And then looking at it using algebra, a positive a plus negative a, once again, is going to equal to 0. All examples of additive inverses. Let's reset this one and keep moving here. Example number 3. I think we're going to take and hold off. Nah, let's do this one anyhow. A hiking trail begins at an elevation of 150 feet above sea level. It leads down to the shore of the ocean, which has an elevation of 0 feet sea level. And it says, what is an integer that represents the change in elevation of the trail? So all you have to do, you started at 150 feet. That means you're going to go down 150 feet to it. So the integer that represents the change in elevation is just going to be negative 150 feet. That's all there is to doing that. Do they have anything else of value here? Nope. So we're going to reset that one, and then we're going to take and give you guys one. Go ahead and pause the video and do this one on your own. Did you get it done? Let's take a look at it. Jaden's bank account balance is a negative $13. Jaden bounced a check. Bad Jaden. He does not, how much does he need to deposit in his account to bring it back to 0? Well, the additive inverse of a negative 13 is just going to be a positive 13. Check your answer. The answer checks. It really is that easy to do these. We're going to go ahead and stop video 1 here. Come back and watch video 2 in a minute to continue our lesson on adding and subtracting integers.